Okay, today I'm going to be teaching you about functions, function tables, and all the things dealing with them. It is probably one of the most key concepts of Algebra 1 is what is a function and what is not a function. Now, over the years, I've seen a lot of ways to explain functions, but I think over the last couple of years, I've really nailed it down of the best way to understand what a function is. When you see the word function, I want you to think of a machine. And in this machine, what you're doing is you're putting a number into the machine. So we're going to put a number into the machine. We'll call that the input. And then it's going to split out an answer. We're going to call that the output. So in and out, okay? We put a number into the machine. We get an answer out. Now let's say I put a 1 into the machine and it gives me a 2 out. And then I put a 2 in the machine and it gives me a 3 out. Then I put a 3 into the machine and it gives me a 4 out. What you want to figure out is, what's the machine doing? Well, it's taking whatever you put into the machine, and let's call that at x, and what are you doing? You're adding 1 to it. All right? So you put a 1 in, you get a 2 out. You put a 2 in, you get a 3 out. Put a 3 in, get a 4 out. If I put a 1 in again, what should I get out? A 2. If I put a 1 in again, I should get out a 2. This machine is functioning correctly because every time I put a number in, I should always get the same number out. If for some chance I put a 1 in and now it gives me a 3 out, now it's not a function anymore because I put a 1 in and it gave me a 3 out, but before I put a 1 in, it gave me a 2 out. This machine is not functioning correctly. So let's try another one. I know that probably doesn't make too much sense yet, but it is a concept that takes a little bit of time to understand. So input, output. All right, so let's say I put a 2 in and I get a 4 out. I put a 3 in, I get a 9 out. I put a 4 in and I get a 16 out. Okay. What's the rule that this function is following? Well, it's taking whatever you put in, let's call it x, and you're squaring it. All right, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if I put a 1 in, I will get a 1 out. All right? If I put a negative 1 in, then I'm going to do negative 1 times negative 1, which is 1. Now you may look at this and say, well, I got the same number twice. That can happen in functions because what's the rule? X squared. And it just so happens that 1 squared is 1 and negative 1 squared is 1. So they have different inputs, but they have the same outputs, and that's okay. That happens in mathematics all the time. In fact, we could make up an equation that had lots of ones that had the same output. What cannot happen, it's okay if you have 2 of the same output. There's nothing wrong there. But if I put a 1 in again, and now it gives me a 2 out, that can't happen because for every time I put a 1 in, I should get a 1 out if the machine is functioning correctly. If I put a 1 in and now it gives me a 2 out, the machine's not working correctly anymore. It's not functioning correctly. It's no longer a function. So I say all that, so let's dumb this really far down for ourselves. In this lesson today, we really don't care what the rule is. All we care about is whether or not it's a function or not. So let's say the input or the x's and the y's. Let's say I put a 1 in, I get a 2 out. I put a 2 in, I get a 6 out. I put a 3 in, I get a 2 out. I put a 4 in, and I get a negative 3. Now you may be looking at this and saying, well, that's weird. I don't understand the rule. How is 1 becoming 2? Oh, it's plus 1, or it's times 2, but it doesn't work here. That's not what this lesson's about. We could make up a rule that could follow this. All right? All you care about today is, can you look at this table and tell me, is this a function or is this not a function? Now remember what a function is. Every time I put a number in, I should get the same number out. So looking at this, I put a 1 in, I get a 2 out. You may look at these two and say, ooh, that can't happen. I put a 1 in, I get a 2 out. I put a 3 in, get a 2 out. Yes, that can happen. Remember, when you square numbers, you end up with two different inputs with the same output. That's okay. What's not okay is if I then put a 1 into my machine and it spits out a 5, That is not okay because now I put a 1 into my machine and I got a 2 out. I put a same 1 in my machine and now I got a 5 out. That can't happen because now the rule has changed. The machine is not functioning correctly. Hope that makes sense. Now, for things that are functions, so I put an X in or the input. If I put a 1 in, I get a 2 out. If I put a 2 in, I get a 3 out. If I put a 4 in, I get a 5 out. You can look at the table to see if it's a function, but you can also look at the graph. If I graph these points, 1, 2, so 1, 2 would be around somewhere around here, yeah? And 2, 3, let's see, 1, 2, 1, 2, 3, probably about there. 4, 5, 1, 2, 3, 4, 5. 4, 5 is somewhere around there. What you can do is you can make a vertical line. Forget that for a minute. What you want to do is if you want to see if two dots are lined up vertically to each other. So as I look at these dots, if any two dots line up vertically to each other, it's not a function. So looking at these, that is a function. Now, if I then graphed another point, let's add another point to this graph. Let's say 1, 5. That means I put a 1 in, I get a 2 out, 2 in, 3 out, 4 in, 5 out, 1 in, 5 out. Now I graph that new point, 1, 5, and that dot is right here. And you'll notice now that these two dots are vertical to each other. We call this the vertical line test. If two dots line up vertically to each other, it's not a function. Because what are we saying? I put the same number in for the input, but I got two different outputs. I put the same number in, I put a 1 into the machine, I put a 1 into the machine. One time I got a 2 out, one time I got a 5 out, the machine is now broken. It's called the vertical line test. It's very useful. If two dots line up vertically, it's not a function. Okay? Very important concept. You can have two of the same y value, you cannot have two of the same x value. All right, so let's go back to the notes. Today we're going to learn about some new words, very key in this class, domain and range. Domain is a big word for the x values, or the inputs, or the independent variables. We're not going to get into independent variables today, but the domain is the x values or the input. Okay? When I say range, I mean what are the y values, what are the outputs. All right? Two things that are not a function. Two of the same x value, and then vertical lines or points. This is a function because if you do a vertical line test, make a vertical line, and if any 2 points line up vertically to each other, it's not a function. This is a function because nothing is lined up vertically with each other. This is not a function because these 2 points are lined up vertically. All right? So, now we have this equation, this example 1. It says, find the domain and the range and determine if each is a function or not. All right, so here's what you're going to do. To find the domain, I'm going to change my line size here. My domain, excuse my horrible writing. My domain is all my x values. It's all my inputs. So what I want to do is make a set, and here's how you make a set. It's a little curve like that. All right. When you say that, when you see a set, it's usually a bunch of x values, it's a bunch of y values. So my domain is all my x values. So what are my inputs or my x values? These are the numbers that I'm putting into the equation. So that's my domain. It's real simple, 0, 1, 2, and 4. All right. The range is just the outputs or the y values. So the range is my y values, 5, 2, 2, 1. Now, sometimes in textbooks you'd see these written in order from least to greatest, but I'm not going to worry about that here. We're just going to write them out. All right. Now, That was my first thing. Tell me what the domain is. The domain is just the inputs. That's easy. And you write them in a set. And the range is just the outputs, or the y values. And you write them in a set. The second half, is this a function or is this not a function? Well, here's what you do. Go back to what we were talking about a few minutes ago. If you have two of the same x values, but different y values, it's not a function. So let's do this. I put a 0 in, I get a 5 out. Okay. I put a 1 in, I get a 2 out. I put a 2 in, I get a 2 out. You may be thinking right now, well, that's not a function. But yes, it is. I can't have two of the same inputs. I can have two of the same outputs, but I can't have two of the same inputs. So this is a function. Is this a function? Yes. I don't even care if I have two of the same inputs. I care, or two of the same outputs. I care, do I have two of the same inputs? So let's look at the next example. Your notes are a little bit better than this. I apologize for that. I put a 1 in, I get a 5 out. Put a 3 in, 2 out. 4 in, 2 out. 4 in, 1 out. So let's write the domain real quick. Well, the domain is going to be 1, 3, 4, 4. Some textbooks don't write it twice, but we're going to write it twice, okay? The range is the outputs. So it is 5, 2, 2, 1. All right? Second half of the problem. Is this a function or is this not a function? Well, what I need to look at is if I have two inputs but different outputs, it's not a function. I put a 1 in, I get a 5 out. I put a 3 in, I get a 2 out. Everything's okay so far. I put a 4 in, I get a 2 out. That's okay. Put a 3 in, get a 2 out. Put a 4 in, get a 2 out. Maybe there's some weird rule that makes that work. But here is where it's no longer a function. Right here tells me that it's not a function. I put a 4 in, I got a 2 out. Then I put the same number in, I should get a 2 out, and I don't. I get a 1 out. And because I put a 4 in and got a 2 out, then I put a 4 and got a 1 out, this machine is no longer functioning correctly. It's not a function. Because every time I put a 4 in, I should get a 2 out based on this table. Not a function. Two different outputs for the same input can't happen. All right. Next example. The domain, I'm just going to abbreviate it now. The domain is 1, 3, 4, 4. The range is 2, 8, 10, 12, right? Is this a function or not? Hopefully by now it's starting to make sense to you. Right here is the giveaway. It's not a function. I put a 4 in, I get a 10 out. If I put a 4 in, I should get a 10 out again, and I don't, so it's not a function. All right? If I was to graph those points, just do a quick little sketch of this, okay? If I was to graph those points, let's say 1, 2 is about right here, 8, 3 is about here, 10, 8, 3, 3, 8, 3, 8 is about here. Ignore that point from a minute ago. All right, so we did 1, 2 is about there, 3, 8 is about there, 10, 4 we'll say is about here. Did it again, didn't I? 410 is about here, and 412 is above it. It's about here. And what you'll notice is those 2 points are vertical to each other, and that's another reason it's not a function. All right? Back to this, the notes here. Another thing we have here is called a function map. And it's really not that hard. What you want to do is when you see a function map, and you will see these every once in a while, the best way to do this is to make a table out of them. So we just make a quick little table. input, output. And all I do is follow the arrows. I put a 0 in, I get a -2 out. Okay, so I put a 0 in, I get a -2 out. Then I put a 0 in and I get a 1 out. Okay, put a 0 in, get a 1 out. Then I put a 1 in and I get a 2 out. Put a 1 in, get a 2 out. Then I put a 2 in and I get a 1 out. 2 in, 1 out. Then I put a 3 in and I get a 4 out. There we go. So I make that first. And all I had to do is list my domain and list my range. My domain is 0, 0, 1, 2, 3. My range is -2, 1, 2, 1, 4. Okay? And then I have to ask myself the question, is this a function or is it not a function? Now, I don't care that I have two 1s. So I have a 1 there, I have a 1 there. Doesn't matter. What do I care about? If I put a number in, I should always get the same number out. And if I look at this problem, I put a 0 in, I get a -2 out. If I put a 0 in again, I should get a -2 out, and I don't. Right here is the key. This right here is why it's not a function. If I was to graph those 2 points, they would be vertical to each other, and that's not a function. So is this a function? No, it's not. Not a function. All right. Then we have our next section. We have a bunch of points, and we need to tell me what the domain and the range are. So to find the domain and to find the range, what I would do again if I were you, instead of just trying to read it, I would quickly make a table with those values. All right, so what's my first value? 0, 1. So my x and my y, remember x and y are the same as input, output. So I have 0, 1 as a point, and I have 0, -2 as a point, and I have 1, 2 as a point, and then I have 2, 1 as a point, and I have 3, 4 as a point. Right? So my domain is all my x values. So 0, 0, 1, 2, 3. My y values are 1, -1, oops, sorry, -2, 2, 1, and 4. All right? And then I have to ask the question, is it a function or is it not a function? There's a lot of reasons this is not a function. Let's go through them. First thing, I put a 0 in, I get a 1 out. I put a 0 in, I get a -2 out. Right there, not a function. The other way I could do this is I could quickly just look at this table. If I have 2 points that are vertical to each other, which I do, that point and that point are vertical to each other, right there is another reason it's not a function. Got it? Real simple. Hope by now this is making sense to you. All right, second half of your homework tonight. You are going to have to use the equation, the function rule, to then figure out what the outputs would be or what the range would be. So you're going to put these numbers in for the domain. And remember, domain is a big word for x. So I'm going to put these numbers in for x, and I'm going to figure out what the range would be. Okay? So the whole point of this right here is to calculate what the range would be. So I'm going to find the range of this equation. So first step, I put a 1 in for x. So I get 2 times 1 minus 1. Well, 2 times 1 minus 1 is 1. Do it again. 2 times 2 minus 1 is 3. 3 times 2 minus 1 is 5. 4 times 2 minus 1 is 7. 5 times 2 minus 1 is 9. Okay? What is my range? 1, 3, 5, 7, 9. You do not need to tell me if it's a function or not, because obviously this has to be a function, because I'm putting my numbers in, I'm getting a number out. And as long as I don't make a mistake in my math, it's going to be a function. So you don't have to tell me if these are a function or not. By their very definition, they're following a rule that's not changing. It's a function. All right, let's do the second one. Same thing again. You put a 2 in, so let's do that. Put a 2 in. 1/2 of 2 is 1. Let me write the first one out for you. 1/2 times 2 plus 10. Well, half of 2 is 1, and 1 plus 10 is 11. Do the second one. Half of 4 is 2, plus 10 is 12. Half of 6 is 3, plus 10 is 13. Half of 8 is 4, plus 10 is 14. Half of 10 plus 10 is 15. All right? So my range is 11, 12, 13, 14, 15. And I believe there you have it. It's a real simple concept once you get this basic idea down. So let's summarize really quick. When you see the word domain and range, think x value, y value, input, output, independent, dependent. We'll get to that another day. What is not a function? If you put 2 of the same x values in, 2 of the same inputs in, you should get the same output or the same y value. If you put the same number in twice and you don't get the same number out, it's not a function. The machine is not working correctly. It's not a function. And also you can use a vertical line test. If 2 dots line up vertically to each other, it's not a function. Hope this makes sense. Have fun with it.